Ever wondered if a robot replication apocalypse could turn from a sci-fi plot into our reality? Well, we've all seen the movies. Autonomous robots replicating themselves at will often play the villainous role. They're depicted as machines of destruction, overwhelming our heroes with sheer numbers. But is this just fiction, or could it be our future? The concept of self-replicating robots isn't new. It's been a staple in science fiction, from Ultron's drone armies in comic book lore to the Pharaoh machines of the Horizon video games. Yet beyond the silver screen and the pages of novels, self-replicating robots are becoming less of a fantastical concept and more of a technological reality. These robots aren't necessarily the harbingers of an apocalypse, far from it. They're machines designed to replicate themselves to perform tasks, from building cars to crafting medical instruments. Indeed, self-replicating robots don't necessarily spell doom. Let's delve deeper into their real-world applications. So, what does a self-replicating robot look like in reality, and how far are we from their mass production? Well, let's dive into the fascinating world of self-replicating robots, and you might be surprised to learn that they are not as far-fetched as they seem. Currently, self-replicating robots are made up of a few different parts that can be assembled with magnets in various ways, depending on the task at hand. Picture a large mechanical inchworm that can lift and move parts from place to place, attaching those parts to a larger structure or even another robot. With this design, these bots have the potential to work together to build anything from airplanes to houses and even structures in space. Now let's talk about their limitations. At present, these robots need a bit of help to replicate. They're built from pre-made parts, which an existing robot can connect together to create a new one. But here's the catch. Someone has to make these parts ahead of time. These robots can't just venture out into the wild and start building new robots from any random materials they find. Interestingly, human intervention isn't required in the replication process itself. A computer program calculates how many robots are needed for a task, and then it instructs each robot to start building the structure or even a copy of themselves. It's a fascinating process, isn't it? So how can these self-replicating robots contribute to various industries? In construction and manufacturing, they could revolutionize the way we build, making the process more efficient and less labor-intensive. In space exploration, they could construct structures or repair damages, reducing the risks for human astronauts, but at this stage they are still not completely autonomous. These robots are programmed to perform individual steps. They don't have the ability to think or act like humans. They don't have artificial intelligence, and they still need us humans to build their parts. While these robots are impressive, they still rely on human intervention. But what if they didn't? If these robots could fully self-replicate, would they pose a threat or open up new possibilities? This is a question that's been stirring in the minds of scientists, tech enthusiasts, and futurists alike. The possibilities are indeed exciting. Imagine robots that could self-replicate to perform tasks beyond human capabilities, from constructing complex structures to exploring the farthest reaches of space. These robots could revolutionize industries, making us more efficient and freeing up time for us to focus on tasks requiring human creativity and insight. But with these advancements come concerns. What if we lose control over these self-replicating robots? What if they become so efficient at replication that we cannot stop them? These concerns are not unfounded. In fact, they are deeply rooted in our understanding of technology and its potential to grow beyond our control. Consider the paperclip maximizer, a thought experiment that illustrates this potential risk. Imagine a robot, highly advanced and powerful, programmed with a single task: to make paperclips. We set no limits to its operation, and the robot becomes so focused on its task that it consumes everything to create paperclips, turning our planet into a giant factory of paperclips and paperclip-making machines. This example, while seemingly far-fetched, highlights the importance of establishing guidelines for our self-replicating robots. It's not enough to create advanced technology. We must also ensure that this technology aligns with our values and serves our needs without causing harm. So, how do we navigate this? First, we need to ensure that the robot's objectives align with human values. This means programming them with specific tasks and setting limits to their operation. We also need to maintain control over the replication process, possibly by requiring human intervention at certain stages. It's not about stifling innovation, but about creating a balance. A balance between leveraging technology for progress and ensuring that this progress doesn't cost us our planet or our humanity. As we stand on the cusp of a robot revolution, it's critical to keep future tech in check, ensuring that our creations serve us, not the other way around.